This is First Coast Math Clinic with Lesson 3, an Introduction to Functions from Unit 8, Functions. The goal in this video is to determine if a relation is a function. So what is a function? A function is a relation in which each value in the domain is paired with only one value in the range. So to determine if a relation is a function, we're going to look at our domain, and that domain has to be paired with only one value from the range. So just a quick review of our domain. The domain is a set of all x values in the relation, so our input. So we're going to look at our x values, and our x values or our domain has to be paired with only one value in the range, and the range are the set of y values in the relation or our output. This can get a little bit confusing. So we're going to go through a couple different examples. We're going to get into kind of a real world example that'll hopefully make this make sense, and then we'll get into some numeric examples where we're looking at sets of ordered pairs and mapping rules. So let's get into an example. So a function, as we said, is a relation in which each value in the domain is paired with only one value in the range. And this relation can get a little bit confusing. So we're going to look at a couple different scenarios and look at the relation between the domain and the range and figure out, based on the relation, based on the relationship between the domain and the range, is that relationship a function or not? So hopefully, if you're having some difficulty identifying whether or not a relation is a function, the next activity we're going to do for the next few minutes make a little bit more sense. Right? So we're going to get into 3 different scenarios, and we're going to ask, are those scenarios a function? So here's our first scenario. A car raffle was held with 5 winners. Each winner won a different car. So we've got our 5 winners. We have Sam, Tyler, John, Allison, and Bob. And Sam won a Maserati, Tyler a Ford Mustang, John an Audi, Allison a BMW, and Bob won a Lexus. Right? So in this scenario, the winners are our domain, so that's our input, our x values, and the output are the cars, so that's our range or our y values. And we can map this and set up a mapping rule and map our winners to our cars. So map Sam to the Maserati, Tyler to the Mustang, John to the Audi, Allison to the BMW, and Bob to the Lexus. If you want to review on different ways to represent relations, you can check out the link for the video that's going to appear right now. So if we're looking at this relation, is each value in the domain, our winners, paired with only one value in the range? So does each person have access to only one car? So that's basically what we're asking. Does each person have access to only one car, right? And the answer is yes. Each person has access to only one car. Sam only has the Maserati, Tyler only has the Ford, John the Audi, Allison the BMW, and Bob the Lexus, right? So for scenario 1, yes, this is a function. All right, so scenario 2, situation changes a little bit. Bob's Lexus was repossessed by the IRS. Luckily, Allison agreed to share her BMW with Bob. So that Lexus is gone. So we can change this relation a little bit. So the Lexus is gone. Bob doesn't have it anymore, but luckily Allison is sharing her BMW with Bob. So we can redo this mapping rule now. So now Sam still has the Maserati, Tyler the Ford Mustang, John the Audi, Allison the BMW, and Bob the BMW. So we're asking, well, is this a function? So our question is, does each person still have access to only one car? Right? And the answer still is yes. Right? Allison has access to the BMW and Bob has access to the BMW. They still have access to only one car, just that BMW. So this is still a function. Okay? So even though Allison and Bob are sharing that car, this is still going to be a function because each value in our domain the winners are still paired with only one value in our range, the cars. All right, let's look at our third scenario. John entered a second contest and won a Lamborghini Aventador. So here's our Lamborghini, and now we can update our mapping rule and draw our arrow from John to the Lamborghini. So now our question is, does each person have access to only one car? Is each member in our domain paired with only one value in our range? Is each winner paired with only one car? So now the answer is going to be no, in particular because John is paired with the Audi and Lamborghini. So John's paired with the Audi and the Lamborghini. So because of that, because our value in the domain here is paired with multiple values in the range, this relation is not going to be a function, okay? So we went through 3 different examples. First two were functions. Third one is not a function. All right, so let's see if we could transition these 3 examples to some actual examples with ordered pairs and mapping rules and determine if they are functions or not. Okay, so we got some ordered pairs here. So number 1, we've got 2, 4, 3, 7, 6, 9, 5, 8, and 1, 10. So the first value are our domains. The second value is our ranges. And if we want to write a mapping rule just to help us to illustrate what this looks like, so we've got 2, 3, 6, 5, and 1. And then for our range, we've got 4, 7, 9, 8, and 10. 2 to 4, 3 to 7, 6 to 9, 5 to 8, and 1 to 10. So each value in our domain, our x values, are paired with only one value in our range. So yes, this is a function. So what about number 2? So our domains again are the first values. So our x values. So we've got 2, 3, 6, 5, and 1. Our range, the y values, just 4, right? We have the same value. We only have to write that value once. So all those values are paired with 4, right? But each value in the domain paired with exactly one y value or one value in the range? Answer is yes. So this is a function. And what about number 3? We've got 2, 4, 2, 7, 6, 9, 5, 8, and 1, 10. So let's set up our mapping rule. It's a little bit easier to see the relation if we set up a mapping rule. So 2, 2, actually just have to write that once, so let's keep 1, 2 there. 6, 5, and 1. Our y values, 4, 7, 9, 8, and 10. So 2 is paired with 4, 2 is paired with 7, 6 is paired with 9, 5 is paired with 8, and 1 is paired with 10. And we notice here, all right, that 2 is paired with 4, and 2 is paired with 7. Because we've got 2 arrows coming off of that x, this is not a function. Two is paired with 4, and 2 is paired with 7. So because of this too, this is not going to be a function. And again, if you kind of look at example, the mapping rule for 1 and 2, and compare it to number 3, you can kind of see the difference. It's not going to be a function when you have multiple arrows coming off of our x value. All right, let's do 2 more examples. So number 4 and 5, we've got mapping rules. So number 4, we notice that we've got -4, -2, 1, and 3. Well, for each of these, we only have one arrow. We only have one arrow coming off of each of these x values, right? So -4 is only paired with 5, -2 is only paired with 6, 1 is only paired with 6, and 3 is only paired with 7. Even though this 6 is paired with multiple x values, since these x values are only paired with one y value, number 4 is a function. But for number 5, right, if we look in particular at this 1, 1 is paired with 6 and 1 is paired with 7. So if we were to write this as a set of ordered pairs, we would have -4, 5. -4 is paired with 5. -2, 6. 1, 6. 1, 7. And 3, 7. And because 1 and 7, 1 and 6 and 1 and 7 are paired with each other, or 1 is paired with 6 and 1 is paired with 7, this is not going to be a function. So it's not a function. 1 is paired with 6 and 1 is paired with 7. Okay. All right. So this was lesson 3, an introduction to functions. The next couple videos, I'm going to do some more examples with functions, determining if relations are functions, in particular looking at graphs of functions. I hope this helped you guys determine if a relation is a function. If you like this video, leave a like, comment, and subscribe. First Coast Math Clinic.